Find the intervals where the function is increasing or decreasing, and then find any local and absolute extreme value where the function f of x is 1 over x plus x minus 1. We will need the first derivative. We rewrite f of x equals x times x minus 1, the whole quantity, to -1, because this is the reciprocal. Alternatively, we can use the quotient rule and then the product rule inside the quotient rule. F prime of x is -1, and then we lower the exponent by 1, -2. We keep the inner function inside the bracket because we never evaluate the derivative at the derivative, but we multiply the derivative of the inner function using the product rule. The derivative of x is 1 times x minus 1 plus, we keep the first factor and we multiply the derivative of the second factor. The derivative of x minus 1 is 1. Simplifying this, we have -1 over x times x minus 1, the whole quantity squared, multiplied x minus 1 plus x. And this is negative x plus x is 2x, then minus 1 over x squared times x minus 1 squared. This is f prime of x. We then determine the critical points. This f prime, first, it has the denominator, so it is undefined, where the denominator is 0. The denominator x squared, x minus 1 squared, is 0 when x equals 0 or when x equals 1. These are the critical points, but also the critical points can be found when the derivative is 0. This derivative is 0 when the numerator is 0, but the denominator is not 0. And so we set the numerator equal to 0, minus 2x minus 1 equals 0, 2x minus 1 equals 0, and so x equals 1 over 2. X equals 1 over 2 is also another critical point. So there are 3 critical points here. X equals 0, x equals 1/2, and then x equals 1. These are the cut points. Negative infinity to infinity is being cut by 0, 1/2, and 1. We now have 4 subintervals because there are 3 cut points. We test the sign of the derivative in each of these subintervals. For the first subinterval, we can pick any number, x equals -1 for example. We plug -1 into f prime of x. We have negative of 2 times -1. 2 times -1 is -2. -2 minus 1 is -3. -3, and there's a negative in front, so the numerator is positive. If we plug -1 into the denominator is the product of 2 squared, so it is always positive. We only need to check the sign of the numerator in this case, because the denominator, again, is always positive in this case, being the squared. When we plug in -1, we see that the numerator is positive, so f prime is positive throughout this interval. We then move on to the next interval, where we pick a number between 0 and 1/2. X equals 1 over 4, for example. We plug x equals 1 over 4 into the numerator. Remember that we do not need to check the denominator in this case. 2 times 1 over 4 is 1/2. 1/2 minus 1 is -1/2. The negative in the front make it positive. And so f prime is positive in this interval. This is the sign of f prime only. For the next interval, we pick 3/4. 3/4 is between 1/2 and 1, and we plug this into, again, the numerator. 2 times 3/4 is 6/4. 6/4 minus 1 is positive, and so the negative sign in front would make it negative. And for the last interval, we can pick any number greater than 1, x equal 2, for example. 2 times 2 is 4, 4 minus 1 is 3. The negative sign in the front makes it a negative. Before we write the interval where the function is increasing or decreasing, we see that f of x is a rational function and the denominator is 0 when x is 0 or when x equals 1. So we need to take out those two values. Now, f is increasing on the interval negative infinity to 1/2, but we cannot go through 0, so we have to stop at 0. The function is increasing from negative infinity to 0, union with 0 to 1/2. The function is decreasing on the interval 1/2 to 1, union with 1 to infinity. Since the function is increasing before 1/2 and then decreasing after 1/2, we say that f has a local maximum at x equals 1/2. To find the local maximum value at this location, we would need to plug 1/2 into the given function. 1 over 1/2 times 1/2 minus 1. This is 1 over 2 times negative 1 over 2, which is 1 over negative 1 over 4, which is the reciprocal of negative 1 over 4, or simply negative 4. This is a local maximum value.